All right. Hello, everybody. Welcome back to the stream. I hope you're having a wonderful day so far. Without further ado, let's go ahead and get right on into this. My name is Michael. Thanks so much for joining me. Today is March 23rd, 2025, and we're back continuing on with our learning in Python and practicing. We're going to be first tackling a little bit of reading, I think, in Fluent Python. And then we're going to be jumping into a Leet code problem, and then we'll work on our project for a little bit. Okay. Let's go ahead and get this on the road. Hope you guys are having a wonderful day so far. Let's go ahead and load up the chat. All right, we got Twitch loaded up as well. There we go. Okay. Nice. And I think we're good. Okay, let's go ahead and jump on in here. All right. Edwards, hey dude, thanks for coming in. It's awesome to hear from you. How are you doing, man? Appreciate you for coming in, jumping in chat. What's going on? How's it going? All right. Shaq Zoid, welcome, dude. Awesome to hear from you. How you been? Welcome back into the stream. It's awesome to hear from you. All right, let's go ahead and jump on into the reading. We are going to be taking a stab at reading some more Fluent Python today. We're going to be into list.sort versus the sorted built method built in. So this is going to be a good opportunity for some of you guys to get some good practice with Python on a more intermediate level. So let's go ahead and dive on in. This is a 2 header. So, right, list.sort versus the sorted built in. Okay, the list.sort method sorts a list in place. We already knew that, right? So we'll say list.sort will sort a list in place. That is without making a copy. Without making a copy. In returns none. Returns none. To remind us that it changes the receiver and does not create a new list. This is an important Python API convention. Functions or methods that change an object in place should return none to make it clear to the caller that the receiver was changed and no object was created. Similar behavior can be seen, for example, in the random.shuffle on S function, which shuffles the mutable sequence S in place and returns none. So we'll say functions that change data structures place should return none to make it clear to the caller that the receiver was changed. Okay. The convention of returning none to signal in-place changes has a drawback. We cannot cascade calls to those methods. In contrast, methods that return new objects, all string methods, can be cascaded into Fluent interface style. We'll say drawback is that functions that return none can not be cascaded. Okay. In contrast, the built-in sorted, right? So this is going to be sorted on the list. Sorted creates a new list and returns it, right? Creates a new sorted list and returns it. It accepts any iterable object as an argument, except accepts any iterable object as an argument, including immutable sequences and generators. Including immutable sequences and generators. See chapter 17. Regardless of the type of iterable given to sorted, always returns a newly created list. Always creates a newly. Okay, both list.sort and sorted take two optional keyword only arguments. Reverse, if true. Both list.sort and sorted list take two optional keyword only arguments. Number one, reverse. Right, so if true, the items are returned in descending order. By reversing the comparison of the items, the default is false. Default is false. Hey, Hawkwig, how's it going? Appreciate you for jumping in and saying hello. Hey, Tim, are we doing Leet code 6.9 today? Is that the square root one? If that's the square root one, then yes, because I did some preliminary studying on that one beforehand because I honestly didn't really know how to come at that one in general. So I wanted to get some pre-studying beforehand about how we can compute square roots without the use of powers. And I have come up with an idea, right, that I think will work. Well, not me per se, but me and the almighty orb. we'll give some credit where it's due. We both came up with some ideas as to where it would be. All right. Hold on one second, you guys. Okay. Sweet. Okay, so right, reverse, and then number two, key. So if true, the items, a one argument function that will be applied to each item to produce its sorting key. For example, when storing a list of strings, key.stir lower can be used to perform a case-insensitive sort, and key length will sort the characters by length. The default is identity function. The items themselves are compared. A one argument function that will be applied to each item to produce its sorting key. For example, key equals length will sort the strings by sort the values by their length. You can also make optional keyword parameter. You can optional keyword parameter key with the min max built-ins with other functions from the standard library. Itertools group by, heap queue, and largest. Here are a few examples to clarify the use of these functions and keyword arguments. The examples also demonstrate that Python's sorting algorithm is stable. It preserves the relative ordering of items that compare equally. So fruits, grape, raspberry, banana, apple. Sorted fruits gives you apple, banana, grape, raspberry. So by alphabet. You print out fruits, you still retain the original list. Sorted fruits reverse true prints out the sorted in reverse alphabetical order. Sorted fruits on length produces these fruits outputted by their length. Sorted fruits length reverse, right? We'll do that in reverse order. We show that fruits is still the same list as above, and then we say fruits, and we call sort on them, actually sorts our fruits list. So I'm going to copy this here. This is a good example of all of these all tied up. Copy image, paste that there like so, and then we'll go down here to the little definitions, and also copy those in right below. Shift V. Perfect. Nice. That looks great. You guys want access to these notes? They're in the link below in my GitHub. I'm good. I've been fired yesterday from my job. Oh no. So I've decided to dive into Python to make the best out of my situation. Currently in the middle of CS50P, and how are you? That's a great, mindset to have. Don't let this door closing, be a door closing. Instead, let it open another. Take this opportunity to, focus on yourself and really reflect. But take this opportunity to also grow in your own skills. It's really a mindset thing. You can let this beat you up, or you can let it, fuel you to the next move. So, but it's obviously sad to hear at first. So I'm really sorry about that, man. Yeah, good. Best of luck to you. How's Python been going? How's CS50P? Highly recommend joining my Discord, link down below if you're not in it. I provide a week by week breakdown of the CS50 courses. I'm going to you know what? I'm going to start that. I need to. You're really inspiring me to get that out. I haven't done the week by week breakdown of the CS50P yet. I need to get that out for you guys, for those that want to take that course and follow along with some guidance from me, as from my reflection on it. And then I also need to update the CS50X week for the last one. I think week 9 and 10 I need to update. So, well, 10 won't be until we finish the final project, really, but yeah. Okay. So that's how, yeah, we already went through that. By default, Python sorts strings lexicographically by character code. This means ASCII uppercase letters will come before lowercase ones, and non-ASCII characters are unlikely to be sorted in a sensible way. Once your sequences are sorted, they can be very efficiently searched. A binary search algorithm is already provided in the bisect module of Python standard library. That module should include the bisect.insort function, which you can use to make sure that your sorted sequences stay sorted. You'll find an illustrated introduction to bisect module in the Managing Ordered Sequences with Bisect post in fluentpython.com website. Much of what we have seen so far in this chapter applies to sequences in general, not just lists or tuples. Python programmers sometimes overuse the list type because it's so handy. I know I've done it. For example, if you're processing large lists of numbers, you should consider using arrays instead. The remainder of this chapter is devoted to alternative to lists and tuples. Okay, so now we have this guy here. When a List is not the answer. The list type is flexible and easy to use, but depending on specific requirements, there are better options. For example, an array saves a lot of memory when you need to handle millions of floating point values. On the other hand, if you are constantly adding and removing items from the opposite ends of a list, it's good to know that a deck, a double-ended queue, is more efficient first in, first out data structure. And if your code frequently checks whether an item is present in a collection, item in my collection, consider using a set from my collection. Collection, especially if it holds a large number of items. Sets are optimized for fast membership checking. So they are also iterable, but they are not sequences because the ordering of set items is unspecified. We cover them in chapter 3. Right, because sets have unique elements. For the remainder of this chapter, we discuss the mutable sequence types that can be replaced lists in many cases. So arrays. If a list only contains numbers, right, an array.array is more efficient replacement. Okay. If a list only contains numbers, an array.array is more efficient, is a more efficient replacement. Arrays support all mutable sequence operations, including the pop, insert, and extend, as well as additional methods for fast loading and saving, such as from bytes and to file. A Python array is as lean as a C array, as shown in figure 2-1. An array of float values does not hold full-fledged float instances, but only the packaged bytes presenting their machine values, similar to an array of double in the C language. When creating an array, you provide a type code, a letter to determine the underlying C type used to store each item in the array. For example, B is the type code for what C calls a signed char, an integer ranging from -128 to 127. If you create an array, quote, B, then each item will be stored in a single byte and interpreted as an integer. For large sequences of numbers, this saves a lot of memory, and Python will let you put any number that does not Python will not let you put any number that does not match the type for that array. Okay. So this is saying that let's see here. I'm going to copy this into the almighty orb here and say, can you please break this down? Efficiency of Python arrays. A Python array is memory efficient, similar to C array. Instead of storing full Python objects, which takes up more space, the array only stores only raw machine values in packed bytes. Comparison with C. In C, an array of doubles stores raw floating point values. Similarly, in Python, an array of floats does not store full Python float objects. It stores just their binary representation. Type codes for storage. When creating an array in Python, you need to specify a type code, a single letter code. So we'll say type codes, a single letter code given as an argument, as a parameter to the array, to insignify to the data type allowance of the array. Right? A single letter code passed as a parameter when creating an array. When creating an array, it specifies the C data type used to store elements, determining this type and size of the values allowed in the array. So we'll say like example, right? The quote B is a signed char, right? 1 byte, range -128 to 127. We have quote H, which is a signed short, 2 bytes, whatever that is. Anybody know what a signed short is? And then we got quote F, which is a float, 4 bytes. Right? Okay. Interesting. Example 2-19 shows creating, saving, and loading an array of 10 million floating point numbers. So create, saving, and loading a large array of floats. So from array, import array. From random, import random. Floats are an array of type D where we are passing in random for every I in the range of 10 to the power of 7. So 10 to the power of 7 integers, we are computing a random integer that many times. We're saving this as type D, which is a decimal. I'm not sure. Floats index -1 produces this. Okay, so in comment 1, we import the array. In comment 2, we create an array of double precision floats, type code D, from an iterable object, in this case, a generator expression. What are double precision floats? Inspect the last number in the array. As you can see, the array.to file and array.from file are easy to use. Array.to file, array.from file. If you try the example, you'll notice that they are also very fast. A quick experiment shows that it takes about 0.1 seconds from array.from file to load 10 million double precision floats from a binary file created with the array.to file. That is nearly 60 times faster than reading numbers from a text file, which also involves parsing each line with the float built in. Saving the array.to file is about 7 times faster than writing one float per line in a text file. In addition, the size of the binary file with 10 million doubles is 80 million bytes, 8 bytes per double, 0 overhead, while the text file has 1,515,739 bytes for the same data. So it does have some overhead for the file itself. Interesting. Lockwig, thanks. I have some savings allowing me to take a few weeks to dive into Python. I'm at lecture 5 and the moment I finish every problem set. Nice, dude. It feels good. good to be less and less reliant on AI and feels things are clicking. That's really awesome. This book is called Fluent Python. It's the one we're reading right back behind me. I have got it linked in my Discord below, a free PDF copy, and you can also access these personal notes that I am taking live on the stream as well. I'll be right back, guys. I'm going to just run to the bathroom really fast. All right. Hello. That Taco Bell hit. No. Just had to been drinking a lot of Coke. I appreciate you guys for joining me here. Let's go ahead and keep on rolling. All right, Chase, dude, Chase from space is back in the building. Hello, Chase. It's awesome to hear from you. I appreciate you so much for joining me. How's it been? It's been going good. You should see this project we got going on. I'll give you a quick little preview here while you're here. This is my small business manager that we've been building live on stream. I've taught myself to Kinter from scratch here, and I've been building this, really trying to focus on proper, data or project, architecture and creation and everything. So this is what we have here so far. Woohoo! Look at that. Yeah. Right, we got the inventory tab with some inventory item. Wait, we can populate in here. We've got the expenses. We can add expenses. Search. We've got transactions. You can commit a transaction, referencing those items, and then you can search them, and then we need to then do the income statement and balance sheet next. So, woo-hoo-hoo, pretty cool. Lots of cool stuff going on. That's going to be our CS50X final project. We are finished with that course in terms of new content. We're just currently writing our final project. So pretty cool. So I think we were on here, right? We were talking to this guy. Yeah. All right, let's go ahead and finish this chunk here, and then we'll call it for the reading for today. How about you? Okay. For the specific case of numeric arrays representing binary data, such as a raster images, Python has the bytes and byte array types discussed in Chapter 4. We wrap up this section on arrays with Table 2-3 comparing the features of list.array of list and array.array. So a list you can add, right? You have both of them. Append both of them. Lists cannot byte swap. Arrays cannot clear. You cannot copy an array, make a shallow copy, but you can support copy.copy. Optimized for copy deep copy. You can append from bytes, binary files, append items from a list if one causes. Interesting. As of Python 3.10, the array type does not have an in-place sort method like list.sort. If you needed to sort an array, use the built-in sorted function to rebuild the array. Array.array, type code sorted array. To keep a sorted array sorted while adding items to it, use the bisect insert function. If you do a lot of work with arrays and don't know about memory view, you're missing out. See the next topic. Okay. Yes, Fluent Python. This is the book that we're reading right now. All right, let's go ahead and shift our focus to a Leet code. We'll go ahead and just do this real quick. Gert. Sweet. Leet code. Give a thumbs up for Leet code right now, you guys. Thumbs up for Leet code here. Let's go ahead and get a problem loaded up. 69 square root. Okay. So for this one, you guys, I've kind of... Let's go ahead and get some music going. How about you? Let's get some tunes going for the stream. Project looks great. Nice. Is it really that far behind for you guys? Where's the stream at for you guys? Ain't no way it's that far behind. No, it's not. Do you publish the binaries on GitHub or somewhere else? I'd love to use it. Yeah, I'll publish it when it's all done. I have it privated right now just because it's my final project and I want to make sure I get credit for it from the course at the end of it. And then when it's completed, I'll publish it and I'll let other hopefully entrepreneurs use it for their own business ventures and tracking their inventory expenses and generating their income statements and transactions and all that jazz. Right? Okay, let's go ahead and get started here. Let's go ahead and load up some tunes. What are you guys studying tonight? Let me know what you guys are working on. All right, here we go. Okay. Delay's about 20 seconds. Yeah, it's not too bad. Okay, so for this one, I've done some preliminary, investigating about how I could go about solving this problem. When I first looked at it, I didn't really fully understand, what was going beyond the roots, underneath behind square roots and everything, and how I could compute it without actually, using it on a calculator or whatnot. We've been blessed with these tools, or using the power function for that matter. So, from my understanding is that the square roots, right? So let's pull up a whiteboard here. It's kind of warm in my apartment. Like the first time in like months it's been warm in here. So from my understanding, we just need to find a value. Like we can brute force basically, or we can do some clever searching, but we need to find a value of, we'll say x, where x times x is as close to as possible our desired, initial value of y, right? So if we're wanting to know the square root of like 25, right? Well, the square root of 25 is it not just 5? Right, which is 5 times 5 to give us 25. So we need to find values within the range of 0 to x, where the x times x is as close to the desired y value, right? So that's my current understanding so far. So how can we do that? Now, we could take an iterative approach, but that would be more brute force in checking every value from this range of 0 to x, right? But we don't necessarily need to do that because, well, with square roots, are you ever, in any square root condition, do you ever have a square root that is greater than x divided by 2, right? Meaning that, is there ever a square root value that is ever on this side of the range? If not, we can immediately disregard this section and just search within these boundaries here of 0 to halfway, right? What do you guys think about that? Anybody have any thoughts? So, what can we do then? Well, if we're going to be searching in a range and we're looking for a specific value under some condition, well then why can't we just binary search again? Right? Why can't, if we can do this linearly, searching numbers number by number, why can't we do it more, strategic and do a binary search across the range and find that value for that condition? That's my thought. So, now to implement this, let's think here. So, given a non-integer x, return the square root of x rounded down to the nearest integer. The result, return integer to be non-negative as well. You must not use any built-in exponent operator, function, or operator. Okay. So, right, that's a good idea, Edwards. So we'll take Edwards' approach here and say, if x is equal to 0, we return we return 0, right? Anything to the 0 power is square root of 0. Wait. Square root of 0 is 0, right? If x is equal to 1, we return 1, right? Square root of 1 is 1. Okay? Now, so now what we need to do is say, so I'm going to try to use the approach, we don't want to slice because we have to use the pointer value, right? So low is equal to would low be equal to 2 in this case? Because we're already checking 1 and 0. And high is equal to x. So we'll compute a middle is equal to, what was that one equation you guys talked about? Was it low minus high plus low divided by 2? Was that the equation to reduce integer overflow for computing middle? I can't remember. Okay. So we compute a middle. We then say well, hold on, I'll wait off on that part. So we compute a middle, right? We then say, if so we say we have a middle now. If what? So if so do I need like a helper function or so I need to call this recursively? My square root on x.
You know, you see rhythms of failure and success and appreciation and rejection and all that.
So how do I update the low?
Well, but you know you survive things.
Okay, so if
It makes you a little easier and
while
interesting. Something will happen. Something will be learned.
while middle, do we do this over while we have a middle value? Is greater than 0? No, we do this, we say while high is greater than low, right? Once high crosses low, then we stop. So then we say if the current value middle times middle how do we determine if it's close to it? Like, how do we determine, like, what is the bound of, so if middle times middle is equal to x, we return middle. If middle times middle is less than x, we are going to call we're going to set high equal to, so if it's less than x, we need to keep going higher. So high is going to be equal to middle, and low is going to be equal to, no, high is going to stay x, low is going to jump up to time for a huge loop. So while middle times middle is equal to x, return middle. No, if middle times middle is less than x, if it's less than x, if the value we're getting is less than x, we want to continue increasing, right? So low becomes middle, and high stays x. Else, right? Right, else we're going to say high is equal to middle. What do you guys think about this so far? Right, so if x is equal to 0, we return 0. If x is equal to 1, we return 1. Else, we set low is equal to 2, and the high is x. Right, so let's pull out our whiteboard. So, right, we have 2. Let's say x is equal to 15. Right? So we have 2 to 15. And our midpoint is 2 plus 15, 17, divided by, floored by 2. So 8 is our midpoint. So we say if middle times middle, so 8 times 8 is greater than. So we set high becomes 8 on our next pass and continue. Low is 2, high is 8. Now we compute middle, which is 10 floored to 5 right? We say, okay, 5 times 5 times 5, or 8 times 8 is 64, right? So that wouldn't work. Lower. 5 times 5 is 25. We got to go lower still. So on the next pass would be 2 to 5. The middle would be computed as 7 divided by 2, 3.5 floored as 3. 3 times 3 is 9. Which our x is 15 here. So we got to go up. Three to 5. Right? Compute that at 4. Four times 4 is 16. That's still high. So then do we need to say if middle we're going to return middle minus 1 if you don't get it here. Oh, I timed out too. Dang it. I timed out, Tim. I timed out too. While high is greater than low. High becomes middle. Low becomes middle. It's over. Right, so then we got 4, which is 16, which is 1 higher, which is still greater than our x value 15, so we want to return back 3, which is 9, which is the because it's in between the square root of 15 is 3.8. So we return 3. So we got this kind of set up almost right. So while high is x, middle 10, return middle. Elif middle, set that and continue. Oh, so we need to set the middle to here inside. We're not recomputing a new middle. And we set low and x out front. Dang it. I infinite loop again. Infinite loop again. So we set low equal to middle when the case it's too low. So I did not mean to exit out of that. So we had 15, 2 to 15, 17, this is 8, it's too high, 8 times 8 is 16, which is greater than 15. So we need to move. So we set middle high is equal to middle. So low is 2 still, high would be now set to 8. So why am I getting infinite loop here then? Else. If it's higher, okay, so if it's middle times middle, it's greater than x, set and high equal middle, it's less than set low equal middle, we continue from there. Again, high is middle, middle is computed, high plus low divided by 2. Why do I get infinite loop here? I'm not really seeing. Let's go ahead and copy this into some dummy Python here. We'll do 69.py. Do while low is less than or equal to high. Okay, try that. So let's do this. X is equal to 15 def my square root. Some value of x. Print my square root x. Okay, so then I want to set point here. Let's debug this. I want to use the debugger here. Okay, low is high. X is 15. Let's step into this. Okay, middle is set to 8. Low is still 2. High is 15, middle is 8. High becomes 8, middle is 8. Continue. High is 8. Middle becomes 5. Still greater than, so we still need to go down. So high should become 5 now. Perfect. Low is still 2. Okay. Low becomes 3. So we detect that it's still greater than at high becomes 5, middle 4. Continue. I'm stuck here. Setting low equal to 3. High at 4. So then if I set this to equal, we restart, dive in, 4, 4, 4, 3, 4, 3, 4, 3, 4, 3. So elif is less than 3, 3, lowest set to middle. So now high is set to 4, low is 3. We compute a middle of 3, because it's floored down from 3.5. 3 times 3 is 9, that doesn't pass. 3 times 3 is 9, which is less than x. So we do this when we set low equal to 3. We set low equal to 3 and we continue. So now low equals 3, high is 4. And we never get out of here. After calculating the mid, add square. Yeah, so you're just using a square variable to check. So if square, so we're getting stuck here on the last pass. So then while high is greater than low, low becomes middle. So high becomes low. So get out of there. Some condensation landed on my mouse. Don't leak in there. I want water to get in there. So how can I fix this loop so we can get out of here? Set low equal to middle. Plus 1. That returned back 3. High equals middle minus 1. So I said middle plus 1. So I say middle minus 1 for the high. Now we pass both. I think that's it. No. Oh. So we're setting middle in the loop. So we need middle equal to 0 at first. Return -1. Can I return? Can I yield?
I'm hardly desperate for anything, really. I feel that whatever is mine is looking for me. I don't feel desperation. The world is pretty much the way it is, and you have your life in it.
So still doing 0 minus 1, return middle.
The difficult things in life. Rather than running, we can get to
So middle's being computed.
where it is pretty peaceful. Extremely powerful.
Here
And it just seems right.
on a local level.
Extremely powerful. Extremely powerful.
So we have high and low now then. So we can do this, I guess. That passes that one, fails that one. Huh.
Extremely powerful.
LF squared less than x, low equals mid plus 1. Yeah.
Extremely powerful.
Else. High mid minus 1, return high. You return high here? Or you return low? So let's return low. We want to return low here. So you return high minus 1 or low plus 1. Either or will work.
Extremely powerful.
So this isn't returning middle here.
And it just seems right. Extremely powerful.
No, say well it's less than or equal to. While high is greater than or equal to low, we compute a middle. So that will compute return high here. Okay. There it is. Boom! We got it, Edwards. You and me, baby. We got it, Edwards. Okay, so I'm gonna take this. I'm gonna bring it into here. Tim, we got it. Okay, so let's step through this one step by step.
Well, I got started by listening to people that play black classical music.
So we set a middle from on 15, high of 15, low of 2. Middle is 8. Middle, 8 times 8 is 64, which is greater than the target x. So we're going to get caught in this third condition here and set high to middle minus 1. So high is going to be equal to 7. Boom. Now we have high of 7, low of 2. That'll give us 9 divided by 4.5 would be 4, right? Middle of 4. 4 times 4 is 16, which is greater than, so we're going to still get hit by this condition. There it is. So now we set high to 4 minus 1, which is 3, and our low is still 2. Now we develop a mid, which is 2. 2 times 2 is 4. So we're going to get caught by this one. We're going to increase low, high. That will make low become greater than high. So it'll do one more pass. So now we're at equal. Right? It'll realize it can't do it here. Oh, that broke, and we return high at that point because low became greater than high. Nice. That looks good. Sweet. That was problem number 69, square root. I was honestly kind of fearing this problem for a little while, if I'm going to be frank with you guys. It kind of scared me, to be honest. I wasn't really sure how to go about this one, but we just learned that square roots are just the number that is closest to the number, right, a midpoint or a value in the range of 0 up to that number, where it's just multiplied by itself. And so you can just do a binary search, searching for that condition, and then return back the digit floor down, right? Sweet. You got it, Tim. I believe in you. Now, I did have to, before I came on stream, I did talk to the Almighty Orb a little bit with my normal, I'm doing problem number 69. I'm really unfamiliar how to compute square roots without using, a calculator or without, or exponents. What suggestions would you make? And it then explained to me that you can just compute a square root. You can try to find a value that's close to the square root by computing some value in the range less than that value by itself. So multiplying it by itself like we did. And you just need to find the value that's closest to it. And if you get a whole value that's in there, then great. But if you don't, then we can't be expected to figure that out within this context here at the moment. So we just floor it and get the value, the closest whole integer down floored. So that was our 23rd Leet code problem. Acceptance is 55.2%. What does that mean? Like on our submissions, we're getting accepted at half the time? I'm not sure, but we'll have to do a little special for the 25th and the 50th and then the 75th and the 100th. Shin, welcome back, dude. I appreciate you for coming in. Thanks for stopping by, and leave a thumbs up on the stream if you guys are here, part of the Sunday crew. Today is March 23rd. We have been teaching ourselves Python. We started off with some Fluent Python. We did some notes on this chapter on getting into sequences, array of sequences, all that jazz. And then we did a Leet code problem today. That was our 23rd Leet code problem. All right, you guys. Today might be a little bit shorter of a stream just because my lady friend is here spending some time with me. She does leave throughout the weeks, so I am able to stream longer during the week. But on the weekends, I do like to prioritize a little bit of my time and spend time with her. So this one might be a little bit shorter, so we'll work on the project just for a little bit here, and then we'll probably wrap it up a little bit early and give it a nice little Sunday hangout. Stop running from foursome. I'll do foursome when you finish that one, Tim. You got. I caught up with school. Wow, you're on Leet code now. Unreal, good stuff. My school had me do an assignment which was analyzing merge, randomize, quicksort, and heap sort in a strange manner. Acceptance is the percentage of people that get it right on Leet code. What did the percentage mean, though, in the context of my completed problems? Okay, so we are currently working on our project right now. I would like your guys' input also. If you guys see how I'm organizing my file system, if you guys have any suggestions of how I could do this better, please suggest. I'm starting to get to the point where it's kind of getting a little bit it could be a little bit dense at times, and I kind of had to break my rules of the original structure I had because I couldn't get my imports to work properly for various stuff. So let me know what you guys think along this. So right now I have just a small business manager directory. In there is an app folder where in there I have classes, tabs, and the app.py. And then outside of the app I have the database just sitting out here because I was having difficulty importing it and getting things working appropriately. Um, I don't know. Okay, so this is what we have so far. Is yesterday we implemented this database manager class, and this now actually will handle the connections and the closing on its own, and then we can also do various fetching as well. So it's pretty cool so far, from my understanding. Um, let's go ahead and so when I fetch inventory, do I want to open and close the database like in that run? That's what I'm trying to figure out as well. Right, so let's go ahead and right now we're fetching headings, expense functions. So we need to fetch the headings. So let's go here and do transaction functions. We'll have def fetch transactions, right? Given a self and an amount. I'm going to copy all of this basically. It's pretty similar, right? Transactions, fetch all, return from transactions, limit, database not connected. Cool. That function's done. Fetch headings. So we're going to fetch transaction headings. Come down here. Paste this here. Let's get some tunes here. Alright, so fetch transaction headings. Transactions, description, database not connected. Cool. So now we'll go in here, go into transactions, transactions, matrix headings equals to database dot fetch transaction headings. We're going to pass those in as transaction matrix headings equals to transaction matrix headings. We're going to go to our transaction matrix in our in our tab, transactions tab. We're going to delete this. We're going to say headings is transaction matrix headings, right? I'm going to take this, I'm going to pass it in as a list, self dot transaction matrix headings equals to transaction matrix headings, and then we come down here and paste it there as well. So now what we have in app.py is we are getting the headings dynamically with our business manager or our database manager, and we're passing those into the tabs themselves via classes, and we are able to now generate the headings. Ah, shoot. Get out of here. There we go. Now if we go here, boom, run. Now we have heading here, and in transactions, we should have column headings. Yes! Woo! Leet code is amazing. Nice. I'm glad you like it, Wing Hong. The simple fact that you did this project with pure Python without any framework is impressive. Good job. Thank you, dude. Appreciate those kind words. Edward, you're awesome. Okay, so now we have that. Let's go ahead and we're passing that in. So I want to, now we need to get items. So let's talk to them. So I am working on my small business manager project, and I am using the database manager class to fetch items and pass those into the tabs classes. I am wondering now how headings passes classes to form the matrix. I'm wondering how I should go about uploading the items into the matrix within the tabs. Should I be calling DB database manager functions within the tab to Kinter class, or other? Good question. Since your database manager is responsible for handling data retrieval, it seems to keep the database interaction centralized rather than scattering them across multiple UI components. Pass data from the controller/main app. Fetch the data before initializing the tab classes. Pass the fetch data to the tab as an argument. The tab class only handles displaying the data in the matrix. This keeps the UI tab classes separate from the database logic and avoids direct pass. If the tab needs to fetch its own data on refresh, you could pass the database manager instance to the class, to the tab class. Then the tab class can call the data. On a refresh button press. Okay, so we'll go here. Then we'll do this. So we're passing in the headings. So instead of passing in the headings, let's pass in the database, right? Which is going to be a class, right? So you pass in the database, and we'll say self.database is equal to the database passed in. We'll go into app.py, and in the transactions, we'll go ahead and instead of fetching the data here and passing that in, what I'm going to do is I'm going to pass in database is equal to database, right, which is currently our database connected database. And then what I'll do is I'm calling this, right? I don't want to do this. It's not a part of the transactions tab. It's part of the transactions matrix. So we'll take that. We'll leave database off. In the matrix, I'll take this, set this equal to the database dot fetch transactions headings. Right? And then that should still work. So let's try that. Okay, do we have transaction headings? Yes, we do. Okay. Hey, Brandon. Thanks for coming in, dude. I appreciate you for joining me. It's awesome to hear from you. What's going on with you? This is a small business manager. It's a pretty not unique, I don't know. It's a cool program in the fact that it'll give, small business entrepreneurs the ability to kind of not worry about their inventory expenses and income statement and balance sheet. It'll be able to kind of generate and do that double entry accounting for them. So you can add in inventory and expenses. You can transact those inventory items as sold items, and then you can then hopefully those transactions will populate an income statement for various years, and then you can generate a balance sheet based off of those income statement, off that was income, right? So yeah, we're working on that right now. So right now we're passing in the database. So, which is good now. So what we'll do is we'll mimic that here. So we'll pass in database equals to database, and then we'll remove this, right? And we'll also do that to the inventory tab. Now to show you guys what's happening, I'll do this, right? So right now, I don't think it'll work because I should have some errors. Maybe it will. Yeah, I don't think it will work. Yeah, because I have unexpected keywords in there now. But now I just removed the headings out of there. So right now, but now what I'm going to do is I'm passing in my current database connection. So I can pass in my current database connection, go to my not income statement, our not transactions either, our inventory tab. Instead of this, we're passing in database, right? We're taking in a database, saying self.database is equal to database, and then right in the matrix, we're going to say that the inventory matrix headings is equal to the database dot fetch expenses headings, right? And then we're going to pass in that into here, and then into here. Okay, so we'll do that. One more time for the expenses now. So the expenses tab. we're going to remove this. We're going to pass in database, remove this database, right? We are then going to pull, this is our matrix tree. Right, we're going to get matrix headings is equal to database dot fetch expenses headings, and then we'll pass expenses. Those get passed, that's fine. Okay, so now if we go back to app.py, we have headings now still. So that one's not working appropriately. So let's go to inventory tab. Inventory headings. So now if we run app.py, sweet, now we have all of those headings there. Woohoo! Hey Don Soap, welcome back. Mr. Gary Gaiman, welcome back. I appreciate you for coming in. If you guys have any suggestions for the project, let me know. All right, cool. So now we're getting those settings we're getting these headings by passing in the database manager. Okay, so instead of passing in the headings, I am passing in the database to the tab, and then using the database within the tab to call the fetch headings and applying that to the matrix within the tab. If you anticipate needing to fetch or refresh data dynamically within each tab by passing the data manager instance into the tab, you can call fetch headings or any other methods. Sweet. Right, so I'll show it this. I'll take my main loop right here and I'll show it this. How does this look? Don't show me code. Here's your structure. Looks solid and organized as a breakdown. The initialization of the small business manager window with fixed dimensions and a non-resizable window. The database manager is being initially instantiated and connected, and before creating any tabs, this ensures when you pass it in. Using TTK Notebook widget holds the tabs. Each tab is initialized correctly when its own association database is passed in where it needed. This keeps each tab's functionality modular and organized. Finally, your app main loop ensures the UI runs and responds. Sweet, it likes it. All right, so now what we can do is we need to now go back to our business manager class, DB manager class, and we need to add in the inventory. We have a fetch inventory already. So what we'll do is we'll go inventory tab. In my matrix, right, I create the matrix, I create the columns, I generate the columns. I then say all inventory is equal to database dot fetch inventory with a quote with a filter, no, with an amount, sorry, equal to quote all. And then we say for item in all inventory, we're going to call inventory matrix tree dot insert the item values equals to item. So now if we run our app.py, so we need parent index. So insert onto tree view dot insert parent index IID KWRs. So, okay. So we do like that, and then IID, unique identifier for the item. IID is equal to item it's a tuple, so index 0 is the IID, right? Because if you print the item index 0 is the number in the database. So if I go here, inventory ID is the first column. Right? So now if we run app.py, we should get an item there. Yes! Woo-hoo-hoo! Look at that, you guys. Nice. 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 That's really good. That's really good. Okay, so now we can do that for the expenses and for the transactions as well. So I'll go down here and copy inventory tab, copy this, go to the transactions tab below the matrix right here where we grid it, put that there. This is gonna be all expenses. Fetch expenses, amount equals all, expense matrix tree. Oh, this is the transactions tab. So transactions, matrix tree. Okay, so This is all transactions. Fetch rate, fetch transactions for item in all for transaction in all transactions. Transactions matrix tree, insert the transaction there. So now if we run app.py, that should still work, but we don't have any transactions currently in there, so that's fine. So now we'll do the same thing from the transactions tab. Do the same thing but for the expenses tab. So in the expense matrix, so right there where we grid it, we do column configure and grid as well, which I don't think I need. If I delete these, run app.py. Oh, I do. Grid. I'm not doing it there. This is the frame. So I'm doing the matrix frame. So all item, this is inventory tab. Items, fetch inventory, transactions, all transactions, fetch transactions, transactions frame. Matrix frame is there. Okay, so that does have it. So I go app.py here. Okay, so yeah, that's why. So expenses. Copy this, expenses tab. Paste that there. Now if you run app.py, it'll be back to how it was. There we go. Okay, so now what we'll do is go transactions. We have for transaction in all transactions, we get the insert. And then in expenses, we need to do the same. So here we have for or all expenses is equal to database.fetch all fetch expenses with a amount equal to quote all. We then will say for expense in all expenses. So this needs to say expenses matrix tree. This be plural. Okay. Then we say expenses matrix tree dot insert start end values equals to, or IID equal to expense index 0, and then values equals to expense transaction item transaction that. So now if we run app.py, everything should still work, which it does, and everything still is there. Perfect. But we don't have any expenses in there or transactions, so nothing's there right now, which is fine. So now our next goal here for probably tomorrow's stream, because I did say this one was going to be cut just a little short, because I'm going to I have my girlfriend here with me over the weekend, so I want to make sure I prioritize my time. The coding will always be there. A lot of condensation on the glass. So now we need to basically have functions for detecting events. So our next goal is to I'm going to hold off on these two tabs until the very end, because these ones are going to be unique, where we're not adding anything or doing stuff, but we are going to be reporting data from these collections. So we need to have these three tabs working in order for these two to work, right? So I'm focusing on these three tabs for now, because our income statement is all the income that comes in from the transactions, right? That's the income statement. Plus, the income statement also reports and all the expenses that took place for that period of time. So the income statement will have a breakdown of year down to the month, right? So it'll have 2025 and then all of the months in 2025. It will then show all the transactions or the sold transactions that took place in 2025 and all the expenses that took place in 2025. It'll then break them down and report them out by that value, and then we'll report them out by months as well. And so that is your income statement, is your income less your expenses. And then your balance sheet takes your income statement, which is an asset, combines that with the remaining inventory, which is an asset, reduces any outstanding, expenses or liabilities, and then we'll report out the owner's equity, or the total value of the company at that point in time. And then you can have what's called there's some sort of tracking mnemonic or whatever, not mnemonic, but device for reporting conglomerated or cumulative health of the company. So you can report out since inception, 6% total revenue. And then it'll adjust from there based on continuing time. So that's pretty cool. So we have a cost of 10. And then we have, which that's what's being reported as. So we do need to format these costs a little bit better visually. Right. So that's pretty good so far. So our next task. Hey TiVo OVO, thanks for coming in. How long you been learning Python for? I've been teaching myself for about 7-8 months now. I stream every single day around 7 p.m. PST, teaching myself studying. I start off with learning and reading in books. That's kind of the main resource I've been learning out of is books. I read some out of the books I'm reading, and then we do a Leet code problem to practice our DSA and Python from those books, and then we work on projects to further solidify our skills and build up our resume. So not too long. We've only been coding for less than a year, but we've come a really long way, and then we have a long ways to go, obviously. So thanks for coming in and following me on Twitch. You're awesome, dude. I'm also on Twitch, you guys, as well as YouTube, so feel free to join me. I've been learning Python for about 2 weeks. That's awesome, dude. I started with Harvard CS50P, and then I compounded that with the Python Crash Course book. And I have a conglomeration of my study resources on my Discord. If you would like to access that, go ahead and look up, I don't think I have my Discord linked on my Twitch, unfortunately. So go ahead and look up my name on YouTube, and you'll see my channel on there. Just over 1,600 subscribers. and you can access my Discord through there. I'll have to upload it to my Twitch. Sorry, man, but yeah, it's completely free. It's got all of my resources in there, from books, my personal notes and projects, to kind of like a roadmap. So this should then say, so transactions tabs, this should say search transactions. It's cut off now by the margin. Ugh. It was perfect before. We'll do it, whatever. Okay, so our next goal, you guys, is to build some functions in our within our tabs here that will be able to detect for when they press these buttons, because when they press these buttons, we're going to need to make sure that they have data in there. If they have data in there and that button is pressed, we extract that data and then try to create an item and load that in. So let's ask the AI, how do you detect events like button presses in Tkinter? To detect button presses in Tkinter, you use the bind method for the command options for the buttons. Using the command option, this method is the simplest. You can specify a function to be called when the button is pressed. Okay. So we'll have to go here to our, I'll bring this over. We'll have to go here to our DB manager class. And then what we'll do is we will, within our inventory functions, we're going to do def add item, right? Item to inventory. Right, this is going to take in self. So let me also ask the AI, let me ask it in over here. What is the point of having classes no, I won't do it over here because it just doesn't remember my current approach. Let me say, what is the point for going to having classes for item and expense, etc., when my database is just, saving the instance variables as just DB values in the table, and no longer using those Python objects. Like when I insert into the table, I am just taking the few data points needed to make an item and just inserting those points into the columns. Why would I ever need to make the item class from there if I am never referencing objects? Item objects directly. You raise a valid point. When you're storing data directly in a database, you don't need to reference the Python objects themselves. You might wonder if the classes like item and expense are still useful. Here's why you still might want to use classes, even if you're just storing the instance variables in the database. Data integrity and structure. Classes act as blueprints for your data. They ensure that the data follows a specific structure and that attributes are set correctly. Even if you don't use those objects directly in the database, having a class allows you to organize your data and maintain consistency when interacting with it programmatically. Encapsulation. Even if you're not directly referencing the class objects later, you can use methods inside your classes to encapsulate logic for manipulating data. For example, you might want to calculate certain values like profit or sales tax that rely on multiple instance variables. Okay, so then if I go to edit an individual item, I'll need to generate the class for that item, call the methods to edit, and then insert those values back into the database. So although I'm not really using these objects anymore and saving Python objects, I'm saving DBs, like DB texts, representative of those values, I can still use the class So if the user goes to edit an item that is in the DB, I can call back the item in the data values for that item in the DB, reconstruct the item object using the data points, and then call methods to edit those points, then resave the object as just data values in the DB associated with that object ID number. Exactly, you got the right idea. Retrieving the data. When the user wants to edit an item, you fetch relevant data from the database. This would typically be done via select query. Reconstructing the object. Once you retrieve the data from the database, the item name, price, description, etc., you can use that data to create an instance of the item class. The constructor of the item class would take these values as the arguments. Editing. After the item is reconstructed, use a Python object. You can use the methods defined in the class to modify the attributes of the object. For example, you could have methods to change the price, update the description, etc. Saving changes. Once the modifications are made, you can save the updated values back to the database. You run the update query using the item's ID to ensure you're updating that correct storage. The item object would serve as a convenient way to hold the modified data, and you can simply pass the attributes to the database when saving. So the database would never physically house or contain item Python objects, but just the values associated at a specific unique identifier to an item object that then could be used to recon it. Exactly. The database itself would never store the actual Python objects. Instead, it stores the raw data, the values, name, price, description, etc., associated with the unique identifier. The identifier allows you to reconstruct the corresponding item object whenever you need. Okay. So, DB fetch queries return non-key pair tuples where I have to know the specific order of the values. How could I change this so I could dynamically set the vals? To make sure the database query is more flexible for dynamic setting the values, you can use named columns instead of relying on positional indices. Using SQLite with named columns, if you're using SQLite, you can access the query results using named columns instead of relying on tuple indexes. You can make your code more readable and flexible. You can set the row factory of the SQLite connection to SQL3 row, which allows you to access the data. Example, so con row factory SQLite 3 dot row. Select where ID is equal to item ID. Fetch 1 on the row. Name row name. Name row price. Name row description. So row is the Kircher. Fetch 1. Dynamic in a dictionary of the row, the data. TV, hey dude, welcome on YouTube. Recently I finished my first project. I made a CLI-based banking system with secure user authentication, which hashes the user password using SHA-512. That's awesome, dude. Yeah, I've been learning about hash functions and compression functions in the DSA and Python book that we've been reading. We're currently on sorted maps right now in chapter 10. So that's awesome. We talked about the different types of hash functions that you can use to create these hash values for passwords and sensitive data. We talked about what was it? We talked about, let me look here. I have these are all my notes for DSA and Python, 10 chapters worth so far. Polynomial hash codes. We learned about cyclic shift hash codes. Right? Yeah. I made the program save and use info all users in a separate folder to allow the user to log back into the program. Sweet, dude. You should post a project showcase in the Discord in the project showcases. So add item to inventory. Okay. So this is going to be given an item. So this can be from item class import item. We'll say database manager self.execute. Self.db.execute will say insert into inventory column. So inventory has ID, date purchased, description. Okay, so ID, no, date purchased, description, size, cost, status. Size, cost, status, values, so how many was this? 1, 2, 3, 4, 5. 2, 3, 4, 5. These values are going to be item dot date purchased, item dot description, size cost, item dot size, item size, item dot cost, item cost. 2, 3, 4. Status. Status is by default given. So right, it's given by default. So my item class status is set to inventory by default. So we'll set that actually. Like so. So we'll say try. So if db, if self.db and self.con, then go ahead and insert this into there. Else, we're going to say this, database not connected. So insert into. So let's see how that likes it. Give me some feedback on my add item function. Here are a few things. Ensure proper in the execute method you're passing values directly as separate arguments. However, execute expects the arguments to be a tuple or a list. That's right. Better error handling have a good catching database not connected. However, SQLite can throw different types of errors. Okay. With so with self.db.execute. So now if I want to give hey LOL, thanks for stopping in. Yeah, we got some OOP going on for sure. I had OOP in the previous one, but it was just a big file because of the just because I was manually writing all those menus. Okay, so this adds the item to inventory. And then we say, okay, so event. So let's go back up to the events that we were talking to earlier. Okay, here we go. On button press, event, print. So we'll go to our inventory tab. In the add item, right, we're going to create a function here called def add item on button add item button press. Takes in an instance of this self. You then say we got to give a command. So on this add item button here, we give a command equal to add item button press. We then pass in an event to this. Now I want to check, how can I check, like in a form, that when a button is pressed, all the info is filled out. Bind a button, use a bind button to event, check the fields. Check if any of the entry fields are empty. Provide. Location. Let's give a label. Name. Texas name. The pack. You make a label. Make an entry. Then you have check form. If not, self.entry get.name get. So I'm gonna go like this. I'm gonna take don't show me code. This is my current tab structure. How does this look? Your tab structure looks organized and well thought out. Here's some feedback. Positive aspects. Separation of sections. You've clearly defined the UI into distinct sections. The inventory, the add item, and the search item sections makes it easy for users to navigate. Grid layout. The use of grid layout management appropriate. Tree view. You've laid out a clear structure for entering data into the add item section. The form looks clean with labels. Areas to improve. Add item button actions. The add item button press function is currently empty. This is the functionality for the add item section, so you'll need to implement the logic that reads the input fields, validates them, creates an item object, or calls the database to add the item, and then references the inventory matrix with the new data. Before handling an item, you'll want to ensure that all the fields are filled out correctly, checking that the number cost is a number, description is empty, The search button clearly needs functionality. So, do I need to add self in front of all my stuff under the tab class? Yes, in typical class, like when you've written, you'll need to use self in front of instance variables and methods you want to reference or modify them. Track of the percentage. Now you can access the self.dPurchase entry. Yeah, so if we, okay, so self dot can I control add item frame, replace self dot add item frame. Okay, so now in search item frame, self dot there we go. And then self dot self dot almost there. Okay, so now if I run appy module named item class, Item button press. So now that's working. So then we'll say, okay, I added self in front of all variables. Great, adding self to all your variables looks like it will allow them to persist throughout the lifetime of the inventory class instance. So add item button. Okay, so we'll do that next time. All right, I'm gonna sign off for here today, guys. I really appreciate you guys joining me. This was some good progress on our small business manager project. We were able to add in successfully into our database manager fetch functions for the expenses and transactions, for their headings as well as their individual transactions and expenses. And then what we did in our app.py, instead of passing in the headings into the tabs, what I did is I passed in the database instance itself into each of the tabs. And now what I'm able to do is call that database instance and just do those function calls dynamically, so I can update live within the tab itself rather than having to refresh or whatnot. So it'll be able to call these functions and then populate and update these frames live on the specific event calls, like pressing buttons and stuff. So tomorrow we'll add in the functionality for actually adding in individual items, inventory, and transactions and expenses. And then we will go ahead and move on from there. So thank you guys so much for joining me. Tomorrow is gonna be a big day for getting this up and running and something actually moving into a working UI front end and back end. So tomorrow is gonna be huge. Thank you guys so much for being here. I'll see you then. Bye.